We're not calculating the actual, we're not calculating it yet. What do you think has the what?
If you're done, you should be. But it sounds like you're not done.
Well, I was wondering what the two has the largest current.
Okay.
Or which one?
All right, they're not. Yeah, they came to an agreement this time. Very nice. So largest current, right? Should be pretty easy. All right. So Kevin and Amanda, turn around. Largest current should be pretty easy because all we have to do is trace where the charges would go. Right. So here's our EMF source. The charges leave positive terminal. Right. They all have to go through resistor A. They get to this junction. Some of them will go this way. Some of them will go that way. Right. They'll meet back up, and then all go through resistor B. So the largest current would be resistor A and resistor B. We get the full amount of current that's leaving and entering the battery, whereas these other resistors would only get some of the current. Right? How much, we'll figure out later, but they would only get some. Follow-up issues from anybody on the resistors that are in series with the battery getting more current than anything that's not totally in series with the battery? I'm getting some dirty looks, so ask. All right, the voltage drop. For the voltage drop, I am going to want to simplify the circuit. So first, I'm going to take these two resistors that are on this branch and replace them with a single resistor. Right? So that's going to take longer to draw than it is to actually do. But here's my 5 ohm resistor A. Right? I have a split in the circuit here. I have 10 ohms on the left branch of the parallel circuit. And then I'm also going to have 10 ohms on the right branch because we have a 4 ohm and a 6 ohm resistor that are in series with each other. Right? And then we have a 15 ohm resistor down here. Alright, so that would be my first step in simplifying this circuit. My next step is going to be replacing these now 2 parallel resistors with a single one. And so I'll redraw my circuit, right? I'll do it over here. I still have this 5 ohm resistor at the top. I still have this 15 ohm resistor at the bottom. Right, and now I need to find the combined resistance of these 2 parallel resistors. So I can go 1 over R equals 1 over 10 plus 1 over 10. I don't think any of us needs to show any more work for that. Right, we can all figure out that the combined resistance would have to be 5 ohms. It would be half, right, of either of the 2 individual. So 5 ohms. Now, we should be able to look and address which one has the largest voltage drop. But let me ask if there are any follow-up questions about replacing these 2 parallel 10 ohm resistors with a single 5 ohm resistor. Okay, so the largest voltage drop is going to be for whichever resistor has the largest resistance, and that's pretty clearly the 15 ohm resistor. All right, so that has the largest voltage drop. Follow-up questions from anybody about determining who has the largest current or the largest voltage drop before we go ahead and continue to find how much current is going through resistor D. I'm going to go a little bit faster with this circuit just because I am recording, right? So I'll post this and you guys can look back at it if you want to. I really don't think you should go back to it because you're not going to be asked to do this on one of our tests. Maybe on SAT 2 you probably have to do something like this. But anyway, my next step would be, well, I probably would be helpful to know, well, it'd be helpful to know what? I really don't need to know how much current is in the entire circuit. I can find it, but I don't think I need to. What I think I need to do next is find, because I need to find the voltage drop across this. So let's go ahead. We know that there's 50 volts worth of potential difference applied to the circuit. So yeah, I guess I need to find how much current is in the whole circuit. Otherwise, I don't really know how to find my voltage drop across here.
It gave us the current.
Oh, it gave you the current as 2 amperes. Oh, great. And does that make sense? We have a total resistance of 25 ohms. We have 50 volts, so that totally makes sense. Right, so we have 2 amperes of current. Great, thank you for that little shortcut. So good, so I can find my voltage drop across this 5 ohm resistor. Right, it would be the total current in the circuit, which is, just the current everywhere in the circuit, multiplied by the resistance of just that resistor. Alright, so my current is 2 amperes, and the resistance of just this resistor is 5 ohms, so I have a 10 volt drop across this portion of the circuit. If we stuck a voltmeter there, it would read 10 volts. So now, I want to go back one step to my half simplified circuit, right? And recognize that each of these is going to get those full 10 volts of potential difference, right? Hi. Alright, so we have 10 volts that we calculated across our complicated part of the circuit. Each branch will get 10 volts. So actually, this resistor here would get all 10 volts by itself. But this foursome up here shows, the hardest resistor in the circuit to find the current through. But since these two resistors are in series with each other, right, we do need to kind of find the current for that entire branch. We can't really find the current separately for those two resistors. So how the heck would I do that? All right, I'm going to use Ohm's law again. And if I want the current through this branch, I would use the voltage drop of that branch, which we already said is 10 volts, right? Both branches get the full voltage drop that we calculated here. But then I do need to use the combined resistance of these two resistors. It's both of their resistances that determines how much current will flow through that part of the circuit. So 10 ohms, right? 4 plus 6 is 10 ohms. So I'll have 1 ampere of current. Some of you probably looked at this initially and automatically knew it was 1 ampere because we had 2 total amperes of current, and we do have 2 branches that have the same resistance as each other. So it is going to be half of the current through one branch and half through the other branch. So this actually, even though it looked way harder than the previous one, it wasn't much harder as long as we're comfortable literally adding resistors that are in series with each other. All right, so we've now seen about 4 or 5 different combination circuits. We have about 7 minutes left. So I don't think we're actually going to have enough time to do all of these calculations. Do we feel ready to kind of do one of those combination circuit ones in your foursomes, or do you think we need to do some straight series and parallel ones still? Let's do some straight series and parallel ones first. All right, so let's do section 1. Maybe have as a goal to complete problem 1 and problem 2 from section 1. If you happen to be in a foursome where every single one of you is like expert with this, you can jump to section 2 if you want. But otherwise, I'd really like you guys to work on 1 and 2.